Good, it's working. Okay, so thanks everybody for the talk so far. It's been very interesting. So I'm now in my PowerPoint presentation to talk to you about one of my favorite topics, which is self-driving vehicles. But it's a little bit claustrophobic in this slide, so let's go for a drive. So imagine you're the driver of this vehicle, and this is the scene you can see. And then this happens. Okay, so what do you think is going to happen next? Well, based on our prior experiences of the world, we have some kind of intuition about how people move. And this intuition is crucial for driving a vehicle. However, it's quite a challenging problem because humans are rather unpredictable. But we need to be able to predict where they're going to move if we want a car to drive itself. So let's talk about that problem more formally. So let's say we have a vehicle, as shown here, with a camera attached to it, and within the line of sight of that camera, we can see a person. So we've seen where they've come from, shown here in the green path, and then we want to be able to predict where they're going next. So we can control the car in these kind of dangerous scenarios, and this can be used for both self-driving cars and also driver assistance systems to warn a human driver if a pedestrian is likely to be in the path. However, what if they take the blue path? So we need some kind of framework for predicting the most likely future location of each person in the road scene. And as I mentioned before, this is a very challenging problem for lots of reasons. So here are some examples of humans doing very, very strange things. And the list of possible things that people could do is so huge that if we were to try and manually label all of this data, we would be there for a very long time. And in fact, it's infeasible. So really, we need some kind of system for training a model to predict where people are going to move without manually labeling the data. So we use an approach called machine annotated pre-training. So you'll have probably seen when you take a photo on your phone that each face in the image is detected. So this is an example of object detection, and we use a similar kind of algorithm for detecting people in an image. So rather than drawing boxes around the faces, we use an algorithm to draw boxes around the people. And then we can use this data to train our algorithm to predict, given the boxes in the previous locations, where the person's come from, where do we think they're going to move next? So here I've got an example video to show some predictions from our model. So in green, we have the ground truth. In red is going to be the constant velocity baseline. In blue is an existing work, as shown down there. And yellow is our approach. And see if you can anticipate what's going to happen next. So hopefully that video is not too laggy, but we'll see. So you can see there that we have the person identified in green. And now we're going to show the model predictions. So our model is predicting that this person is going to cross the road, and that is indeed what happens in this case. So here's another similar example. And again, we managed to predict that this person is going to cross the road. Now, I'd like to pretend that this works every single time, but fortunately it does not. So here's an example case where we get it wrong. So here we're predicting that the person's going to walk into the road, and in fact they stop just on the curb. So we use the mean squared error to evaluate the performance. So this is the square difference between all the future locations. And we can see here in this plot that as we use more of this machine annotated data for pre-training, so this is data that's been labeled by our algorithm rather than labeled by hand, the mean squared error is generally declining as we use more of this unlabeled data for pre-training. So, to conclude, we need to be able to anticipate where people are going to move if we want to have self-driving vehicles. However, it's very challenging because pedestrians are rather unpredictable and there's all kinds of different scenarios that may occur. So, rather than manually labeling all this data, we propose this machine annotation method to annotate the data for us, and then we show that this generalizes to a data set of human-labeled data.